Right, part 9, there are 2 more parts. First thing that we're going to start with is a muscle twitch. This is kind of like a sarcomere. Sarcomere was the smallest unit that contracts. A muscle twitch is one contraction. It's the brief contraction to a single stimulus. So it's the minimum amount of voltage that will trigger a twitch. It's called a threshold stimulus. We'll talk more about this once we get to the nervous system, which is still in this unit. So really quick, the periods of the twitch or the latent period. It's the time after the stimulus but before the contraction begins. So there's no change in tension. So it is really, if you think about it, after the stimulus but before contraction begins, this latent period is going to involve that action potential, the end plate potential, right? How long it takes for exocytosis to occur. Voltage, action potential travels down to the axonal terminal. Voltage-gated calcium gates open. Calcium rushes in, triggers exocytosis of acetylcholine. We have an end plate potential. Right, all of that. Contraction period is the time when the tension is increasing, and that will begin as soon as that power stroke. We'll pull those thin filaments so that H zone is getting smaller. The relaxation period is when the tension is decreasing back to the baseline. And it's when ATP binds to that cross bridge, and that cross bridge then releases. And this period is going to be longer than that contraction period. So that's just the muscle twitch. It has these 3 periods: latent, contraction, and relaxation. Okay. So if you remember, one of the characteristics that we said with skeletal muscle is that it is extremely adaptable. So how can we differentiate if we're lifting a light object versus lifting a heavy object? So that is multiple motor unit summation, and it is recruitment. Recruitment, multiple motor unit summation really is the same thing. So this explains how we can have varying degrees of force. So what's going to happen is that as you're trying to lift something, your nervous system is recruiting just a few motor units. If you're trying to lift a suitcase, what's going to happen is this multiple motor unit summation. It kind of tells you it's going to try one motor unit to lift this suitcase. That's not going to do it. It's going to then have a second motor unit, a third motor unit. It's going to keep going until you are successful in lifting the load, if you can lift the load. So above a certain voltage, all the units are going to be recruited, and so maximum contraction occurs. So that's regardless if the voltage increases. Okay, I should say there's really not going to be a lot of segues in here per se. I'm just kind of touching on various parts in the chapter in your textbook, not all of them though. So the staircase effect. TREP is that we're going to see increased contraction in response to multiple stimuli of the same strength. Increased contraction in response to multiple stimuli of the same strength. What that means is I throw a punch, it's going to have a force of X. I immediately throw another punch, it's going to be slightly greater than X. Throw another punch, it's going to be slightly greater than that, so on and so forth. So the force of the contraction is going to increase even though the stimuli is the same strength. Why does this happen? So first, there's going to be increased availability of calcium. Right after the first contraction, calcium is, as soon as relaxation starts, calcium is being sequestered back to the paired terminal cisternae, but that takes a little bit of time. So if you throw a punch and then you immediately throw another one, all of that calcium hasn't gotten back in. So there's more calcium available to bind to troponin. Another reason is that as ATP is hydrolyzed, heat is a byproduct. So as you keep contracting and relaxing, heat is going to be released. We haven't gone over the enzymes, but it shouldn't surprise you that throughout this whole contraction period, there are enzymes that catalyze these reactions. So as we hydrolyze ATP, more heat is released. Those enzymes are going to become more efficient. And here we see, right, the stimuli is exactly the same, and the tension that we generate over time is greater. This is why boxers will warm up before a fight. Right? You would think that they would want to not waste any energy, but they're warming up, and there are other benefits to warming up. I'm not saying this is the only one, but they're warming up so that right once they start fighting, their first punch is going to have the maximum force. All right, muscle tone. This is the slightly contracted state of all muscles, and it doesn't produce any active movements, and it keeps muscles firm, healthy, and ready to respond to stimulus. So all of our muscles will have these periodically slightly contracted states, and that's what muscle tone is. And that's why for a patient that has lost innervation to a particular muscle, it will start to wither away because tone isn't there, so it's not contracting at all, and it can't contract. When we take a look at contraction of skeletal muscle, there are two types of muscle contractions. Your textbook will go into this in greater detail. I'm only going to hold you responsible for what I cover. So we have muscle fibers, and the organs are going to be similar. So the first one we have is an isometric contraction. Increasing muscle tension, the muscle does not shorten. So we're not successful in moving the load. Think of it this way. If you try to lift up something that is 2 tons, your muscles are going to contract, right? But the muscles aren't going to shorten, right? Because you can't move that load. Isotonic, don't confuse this with what we were talking about with hyper and hypo. Isotonic contraction, you are successful. So the muscle will shorten during contraction. So I definitely am going to test you on these two things. So make sure you're okay. We're going to take a greater look at both of these right now. So isometric. So the muscle doesn't shorten or lengthen, and this occurs if the load is greater than the tension that the muscle is able to develop. That's going to be isometric. You can't move it. Right? So this weight is too great. This will contract, but it can't shorten because, like I said, the load is too great. Isotonic is when we are successful, so we're going to decrease the angle of the joint, and we're going to move the load. And we see that right here. Okay, there is one more slide, but this is the end. I'm just going to leave that last slide up for a few seconds. That's just kind of FYI. I'm not going to test you on anything about that. My focus on isotonic and isometric contraction is what I've just covered. Right, so this is going to be the end. And like I said, this is just a clinical view, FYI, up to you.